Now we're going to apply what we've just learned about similar shapes to maps. So first things first, you need to know how to convert between some certain units. For instance, you need to know that a meter is equal to 100 centimeters, and that's something I can write in this form. 1 meter is 100 centimeters, or 100 centimeters per meter. A meter squared is therefore 100 centimeters squared, which is 10,000 centimeters squared, or you can write this as 10 to the 4 centimeters squared. Another unit you need to be familiar with is the unit of, well, the hectare, which is represented with these two letters HA. So a hectare is a unit that can be used to represent areas, and 1 hectare is equal to 10 to the 4 meters squared. So 1 hectare is 10,000 meters squared. I'll just write that. 1 hectare is 10,000, spell it out for you, 10,000 meters squared, or 10,000 square meters. You need to be able to convert between hectares, centimeters squared, and square meters. So here's a problem. It says convert 5 hectares to centimeters squared and meters squared. So let's start with meters squared. Like I just said, 1 hectare is equal to 10 to the 4 meters squared. Therefore, 5 hectares is equal to how many meters squared? It's 5 hectares times 10 to the 4. I'll just show you a technique. Now, if 1 hectare is 10 to the 4 meters squared, it also means that 10 to the 4 meters squared is 1 hectare. So I've just taken the reciprocal of this fraction to give this fraction. So to get the value in meters squared, I'll just multiply 5 hectares by 10 to the 4 meters squared per 1 hectare. What you can think of it this way: the unit of hectares cancels out, and we were left with the only unit here, which is square meters, and that's the unit we're interested in. So 5 hectares is equal to 5 times 10 to the 4 divided by 1 meters squared, which is 5 times 10 to the 4 meters squared. Now to convert 5 hectares to centimeters squared, since you know that 5 hectares is 5 times 10 to the 4 meters squared, all you have to do is convert 5 times 10 to the 4 meters squared to centimeters squared. And as we know that 1 meter squared is 10 to the 4 centimeters squared. So meter squared cancels out, and we're left with centimeters squared. Thus, 5 hectares, which is 5 times 10 to the 4 meters squared, is equal to 5 times 10 to the 4 times 10 to the 4. So 5 times 10 to the 4 times 10 to the 4 divided by 1 centimeters squared, which is equal to 5 times 10 to the 8 centimeters squared. Here's another problem. We need to convert 25 times 10 to the 9 centimeters squared to square meters and to hectares. So let's start with the conversion to square meters. We know that 10 to the 4 centimeters squared is equal to 1 meter squared. So 25 times 10 to the 9 cm squared can be obtained by multiplying this by, well, take the reciprocal of this fraction, you know that 1 meter squared is, you get that 1 meter squared is 10 to the 4 meters squared. So I need to get rid of centimeter squared and obtain meter squared. So the meter squared value will be the numerator, and the corresponding centimeter squared value will be the denominator of fraction. I multiply my centimeter squared value by. The key thing here is that we're trying to get this area, which is in centimeters squared, to meter squared, and the centimeter squared is going to cancel out the centimeter squared, just leaving meter squared. So we just need to ensure that you have your correct conversion fraction. So here this fraction says that 1 meter squared is equal to 10 to the 4 centimeters squared. You can think of it this way: 10 to the 4 centimeters squared for each 1 meter squared, or 1 meter squared for every 10 to the 4 centimeters squared. So anyway, what you're left with is 25 times 10 to the 9 times 1 divided by 10 to the 4. 25 times 10 to the 9 times 1 divided by 10 to the 4. And the only units left, which is meter squared. And what you get is 25. You can do this in your calculator. You get 25 times 10 to the 5 meters squared. Therefore, 25 times 10 to the 9 centimeters squared is equal to 25 times 10 to the 5 meters squared, or square meters. Now let's determine what this value is in hectares. So you want to go from centimeters squared to hectares. So ideally what you want is an expression. I'll have this as an element. So you have your value, and you multiply it by a conversion fraction where the unit you don't want will cancel out, and you'll be left with the units you want, which is hectares. So you want something of the form hectares over centimeters squared. Now we know that 1 hectare is equal to 10 to the 4 meters squared. And we know that 1 meter squared is equal to 10 to the 4 centimeters squared. So meter squared cancels meter squared here, and this gives a 1 hectare times 1, which is 1 hectare, divided by 10 to the 4 times 10 to the 4 centimeters squared, which is 10 to the 8 centimeters squared. So you have 1 hectare for every 10 to the 8 centimeters squared. If this seems confusing to you, then all you need to do is remember that a hectare is equal to 10 to the 8 centimeters squared, and from that you can always write down this conversion fraction. So 25 times 10 to the 9 centimeters squared in hectares, 1 hectare is 10 to the 8 centimeters squared. So the centimeter squared cancels out, and the only unit you're left with is hectares. And what we have is 25 times 10 to the 9 times 1 hectare, which is 25 times 10 to the 9 times 1 hectare divided by 10 to the 8. And this gives 25 times 10 hectares, which is 250 hectares. That means that 25 times 10 to the 9 centimeters squared is equal to 250 hectares. So try and remember that 1 hectare is equal to 10 to the 8 centimeters squared. Before moving on, it's important that you understand this particular concept that has to do with ratios. So let's just consider the following statement. It says, if the ratio of a certain dimension to another dimension, so the ratio of dimension 1 to dimension 2 is A to B, if B is greater than A, then dimension 2 is larger than dimension 1. So let's say I have two shapes. I have a rectangle, call this rectangle 1, and I have another rectangle, call this rectangle 2. If I just focus on the dimension, the length dimension, so call this the length of rectangle 1 L1, and I call the length of rectangle 2 L2. If L1 over L2 is A over B, if B is greater than A, it means that dimension 2 is larger than dimension 1. So let's say L1 over L2 is equal to 5 over 7. Because 7 is greater than 5, it means that L2 is greater than L1. So consider this. It says the ratio of the area of square 1, so I have two squares, or we have two squares. The ratio of the area of square 1 to the area of square 2 is 1 to 200. So the area of square 1 to the area of square 2 is 1 to 200. And it says it asks which square is larger. Because 200 is greater than 1, the area of square 2 is greater than the area of square 1. So square 2 is larger. So which square is larger? Square 2. Well, I'll just underline it there. The next one says the ratio of the length of rectangle 1 to the length of rectangle 2 is 3 to the 2. Which rectangle has the larger length? Well, here it says length of rectangle 1 divided by length of rectangle 2 is 3 to the 2. So in fraction 3 over 2. Which rectangle has the larger length? Well, because 3 is greater than 2, L1 is greater than L2. So the length of, that means rectangle 1 has the larger length. So rectangle 1 has a larger length in this case. Now we're going to take a look at scales, which are essentially reduction ratios. What do I mean? So let's assume that on a map a country is represented with this. A country is represented with this region. So this black line represents the border of the country. Of course, the country is much bigger than this diagram I've just drawn, but this is just a representation on a map, and a reduction ratio has been used, and you can think of that reduction ratio as a scale. So what you do to determine that ratio, all you have to do is find a length on the map and divide it by the actual length in reality. So if there's a point A, let's say this is a point in a certain city, and this point B is another particular point in another city, the distance between these 2 points along, a straight line is some distance, and that's some length, and that's the length on the map. You can measure it with a ruler, but in reality, so let's say in the ruler this length is, let's just say 3 centimeters. So let's say the length on the map is 3 centimeters. In reality, the actual distance between these 2 points could be 100 kilometers, or 100 kilometers, or let's just say 10 to the, I'll just call it something else. Let's say 10 to the 6 centimeters. Let's say that's what the actual distance is in real life. Well, the actual length is 10 to the 6 centimeters. Well, the scale used is 3 cm on the map to 10 to the 6 cm, so a million centimeters in reality. The key thing you need to note is that to determine the scale, the lengths you use, so the length on the map and the actual length, must be in the same unit. So notice I didn't use kilometers and centimeters. I use centimeters for both lengths to determine the scale. So anyway, let's just start with an example. That's the best way to demonstrate this idea. So this example says, well, a map is drawn using a scale of 1 to 100,000. So 100,000 is 10 to the 5. So the same thing as 1 to 10 to the 5. What does 1 centimeter on the map represent? So what does this scale tell us? It tells us that the length of, or let's say you pick 2 points on the map. Well, the distance between the 2 points, or the length of a line joining 2 points on the map, divided by the actual length, or the actual distance between the 2 points, is equal to 1 over 100,000, so 1 over 10 to the 5. So notice that because 10 to the 5 is greater than 1, the actual length is greater than the length on the map. And what this just says is, look, 1 unit on a map is equal to 10 to the 5 units in real life. So 1 centimeter on the map is equal to, or represents, so it's equivalent to 10 to the 5 centimeters, well, 10 to the 5 centimeters in, I'll just say real life, but let's say real life, let's put it that way. Or you can interpret this scale as being 1 meter on the map. So imagine you had a map that was so big where you could fit a meter on it. 1 meter on the map is equivalent to 10 to the 5 meters in the actual, in real life. I'll just say real life. So that's how you interpret the scale. So the answer to the question is simply 10 to the 5 centimeters. What does 1 centimeter on the map represent? It represents 10 to the 5 centimeters in real life. And you know that 10 to the 5 centimeters is equal to what in meters? Well, 100 centimeters is equal to 1 meter. So I can obtain the value in meters because the centimeter cancels out. So I have 10 to the 5 times 1 meter divided by 100, which gives 10 to 3 meters, so 1,000 meters. So 1 centimeter on the map represents 10 to the 5 centimeters. 1 centimeter on the map represents 10 to the 5 centimeters in real life, which is the same thing as 1,000 meters. Here's another example that says the distance between a hotel and an airport is represented by 10 centimeters on a map. So let's say we have a map and there's a hotel somewhere here and there's an airport here, and let's say the straight line distance, so let's assume the straight line distance is 10 centimeters on the map. Of course, this is not to scale. And they're saying that if the actual distance between the two places is 10 kilometers, what scale was used? Well, how do you determine the scale? Well, it's the length on the map divided by the actual length, but they have to be in the same units. So divided by the actual length. What's the length on the map? The length on the map is 10 centimeters, the distance between the two places. And what's the actual distance? So I can interchange length and distance. In this case, distance makes more sense. So distance on the map, 10 centimeters, actual distance is 10 kilometers. So I have centimeters here and kilometers. So I need to make sure the numerator and denominator are in the same units. So that I'll convert kilometers to centimeters. So you need to remember that 1 kilometer is equal to 10 to the 5 centimeters. And because of that, I know that 10 to the 5 centimeters is equal to 1 kilometer. So 10 to the 5 centimeters per kilometer, 1 kilometer for every 10 to the 5 centimeters. So how is this useful? Remember this, please. I can use this to determine 10 kilometers in centimeters, because 10 kilometers will now be what in centimeters? Well, I want result in centimeters, so I want something of, I'll just do that elsewhere. I want something where I have centimeters and kilometers, well, kilometers here, so that kilometers cancel out. So 10 kilometers times, well, something like this. I know that 10 to the 5 centimeters is 1 kilometer. Kilometers cancel out, leaving me with centimeters as the only unit. So 10 times 10 to the 5 centimeters divided by 1. That gives 10 to the 6 centimeters. So now I know that 10 kilometers is 10 to the 6 centimeters. So this ratio here is 10 centimeters. Instead of 10 kilometers, I have 10 to the 6 centimeters. So now I have my scale where the numerator and denominator are in the same unit. So centimeters cancels out. So what I have is 10 over 10 to the 6, which is the same thing as 1 over 10 to the 5. And that means the scale uses 1 to 10 to the 5. So 1 unit on the map represents 10 to the 5 units, well, in real life. So 1 centimeter on the map represents 10 to the 5 centimeters in real life. 1 meter on the map represents 10 to 5 meters in real life. If you're wondering how I got from 10 over 10 to 6 to 1 over 10 to the 5, I just divided the numerator and denominator by 10. Or you can say, well, 10 is the same thing as 10 to the 1 divided by 10 to the 6 is the same thing as 10 to the 1 minus 6, which is the same thing as 10 to the minus 5, which is the same thing as 1 over 10 to the 5. So whichever way you prefer. But so this is our scale. So I can write it as 1 to 100,000. 10 to the 5 is 100,000. There are 5 zeros. 10 to the 5. Here's another example. It says a region in Africa is represented on a map by an area of 30 centimeters squared. Using a scale of 1 to 30,000, find the area of the region in hectares. So in reality, the region will be something, well, let's say this is the region, it's just massive. And then on a map, the same region will be something smaller. But the key thing is the two shapes, the actual region shape and the reduced shape on the map will be similar shapes. And that means if I'll call the map, the shape on the map, shape 1, and the shape representing the actual region, shape 2. The area of shape 1 to the area of shape 2 is equal to any linear dimension of shape 1 divided by a linear dimension of shape 2 all squared, because the representation of this region on your map is going to be similar to the actual region. So we're told that the scale of 1 to 30,000 is used. That means that for instance, 1 centimeter on the map is 30,000 centimeters in real life. And of course, this is a 1 centimeter. A centimeter is a linear measurement, so we know that the ratio of the linear measurement. So linear measurement on the map to a linear measurement in real life is 1 over 30,000. That means that the area on the map divided by the area in real life is 1 over 30,000 all squared, which means A1 over A2 is equal to 1 squared divided by 30,000 squared, which is equal to, you can do that with your calculator and you get 9 times 10 to the 8. So we know that, so like I said, 1 represents the map, and we're told that the area on the map is represented with 30 centimeters squared, and that means A1 is known as 30 centimeters squared, and we need to find the area of the region in hectares, so in real life. So we need to find A2. We need to find A2, but A1 is known. So I'll just move here. So A1 over A2 is 1 over 9 times 10 to the 8. A1 is known to be 30 centimeters squared. So that means that 30 centimeters squared over A2 is equal to 1 over 9 times 10 to the 8. Cross multiply, I get that A2 is equal to 30 centimeters squared times 9 times 10 to the 8, which gives the A2 as, you can use your calculator, 2.7 times 10 to the 10 centimeters squared. I need to convert this to hectares. Well, we know that 1 hectare is 10 to the 8 centimeters squared. So 2.7 times 10 to the 10 centimeters squared in hectares. Well, to do that, I need to eliminate centimeters squared. So I need something like this, conversion fraction of this form, which what I have here, 1 hectare is 10 to the 8 centimeters squared. Centimeters squared cancels out. What I have is 2.7 times 10 to the 10 times 1 hectare divided by 10 to the 8, which gives 2.7 times 10 to the 2 hectares, which is equal to 270 hectares. So the region on the map has an area of 30 centimeters squared, and this area is actually 270 hectares, or 270 hectares, and we were able to deduce this by using the fact that the representation of an expanse of land in real life on a map is going to be similar to the actual expanse of land. So we know that the ratio of the area of the, well, let's say shape on the map divided by the actual shape is going to be equal to the ratio of a linear measurement on the map to a linear measurement in real life, all squared. And that's what was employed. One of the areas was given, so we just made the second area the subject of the formula, and we got, well, 2.7 times 10 to the 10 centimeters squared, which we then converted to hectares as the question requested. We obtained a value of 270 hectares.